In a democratic society, published opinion and public perceptions are the main drivers for political action, not indisputable scientific facts. Cases in point are the European Union's climate change strategy of 10 January 2007 and the Green Package of 23rd January 2008, but also some regional activities in the US and proposed action by US legislative bodies. Those policies and proposals have been justified by the extremist view on climate change. Both AIT, the Inconvenience Truth, and the Stern Report have been thoroughly analyzed and discredited as a one-sided extremist view of the world unsuited for policy decisions. Okay, let me run down some of the key elements of the extremist view. One, there is a significant chance of a temperature increase greater than 3 degrees centigrade, which is close to 6 degrees Fahrenheit, by 2100. Observed global warming in the last few decades is entirely due to man-made global warming, which is not what the IPCC says, but you sometimes hear the statement in the media or by some scientists. There is a significant increase of extreme weather and climate events with future warming, as, for instance, hurricanes, tornadoes, windstorms, extreme precipitation events, and droughts. And those extreme events have already increased as a result of man-made global warming. And further, and lastly, there is a significant chance of a large sea level rise of several meters caused by partial melting of Greenland and or Antarctica. Okay, first question I would like to devote my attention to: is there a significant chance of a temperature increase by more than 3 degrees in 2100? The predicted warming by 2100 depends to a large extent on assumed socioeconomic factors, as for instance population growth, economic growth, energy use growth. It's not so much, I mean, the climate models add a lot of uncertainty, but there's in fact more uncertainty in the socioeconomic scenarios. The key element in mainstream climate model projections is a large positive feedback between CO2, water vapor, and clouds, leading to a two-time CO2 projections of about 3 degrees centigrade as a climate, we just heard about this, climate sensitivity, which is about triple the basic CO2 radiative forcing alone without the feedback parameters. Now, for the presently observed equivalent CO2 concentration, this is CO2 plus other greenhouse gases as methane, the CFCs or N2O, ozone, the forcing is already about 75% of a CO2 doubling. Now, this should have resulted in a warming of close to a degree and a half centigrade or more for climate sensitivity above 3 degrees centigrade, and plus adjusted for oceanic slowing, because the climate system does not react immediately to a greenhouse gas increase, the concentration of the increase, the climate response lags, of course, until it works its way through the system. Over the past 100 years, we have observed a temperature increase of about 0.8 degrees centigrade. Over the last 30 to 50 years, a half degree, and however, only the last 30 or 50 years are being ascribed to greenhouse gases. I remind you of the statement in the IPCC reports, either of 2001 or 2007, which claims that over the past 50 years, the warming has been such and such. So they're talking about the last 50 years and 30 years, but not about the temperature rise of the last 100 years. So there's, of course, a large differentiation. Now, however, if the entire warming of the last 30 or 50 years would be due to greenhouse gases, that warming, which is about a half degree, would only be about 1/3 of what we actually should have expected if the model calculations were correct. Now, if present trends of greenhouse gas concentrations in the atmosphere greenhouse gas forcing increases and global temperature increase, present trends, continue to 2100, temperatures would only increase by about 1.5 degrees, plus minus 0.5 degrees, depending on how you define the trends, which data set you look at. If you do your trend calculations going back 30 years or 50 years. And due to the logarithmic dependence of temperature of CO2 concentrations, would only go up linearly, even if CO2 concentrations continue to increase exponentially. We heard about this before. All right, this is the global not just the global, but the global northern hemispheric and southern hemispheric temperature trends over the past 100 years, actually 140 years. And you can see, as some other of the speakers have pointed out, that there is actually 2 periods of a warming, one between 1910 and about 1940, a period of slight cooling between 1940 and 1970, 75, something like that, and then an increase over the past 30 years. So I would not like to talk about a temperature increase over the last 50 years. I would like to talk about the temperature increase in terms of the increase of the past 30 years. Now, I'm showing a table which I have put together here, in which I show what the IPCC is predicting for the next 100 years, namely a warming of between 1.1 and 6.4 degrees centigrade. And I'd like to compare this with several of the predictions that have been made in the past and the observations. First of all, CO2 concentration. The IPCC 1990, 0.8% per year. The scenarios used in IPCC 2001 and 2007 are based on the SRES, the Special Report of Emission Scenarios. It gives you those values. Observed. Now, I've used the observed period 1987 through 2006, which covers about 20 years. Therefore, about the period, roughly speaking, between the publication of the first IPCC report and the current IPCC report. And you can see here that the observed CO2 concentration increase is much smaller than modeled. The CH4 concentration, the next important greenhouse gas, much smaller. It has, in fact, ceased to increase at all since about 1999. The greenhouse gas forcing increase in watts per square meter in decade, you can see here, lower. And then you have the temperature increase projected 1990, 2001, and 2007. And you can see from this, again, depending on the data set you use, it's in all cases, the observed over the past 20 years is much less than what the IPCC has predicted in 1990 or 2001, or 1995 for that matter, and what has been observed over the past few decades. Now, this is a very important diagram, which comes out of a publication by Jim Hansen in 2004, and which gives you the rate of forcing increase by trace gas. And you see that the rate of forcing increase has decreased dramatically since about 1990. The reason for that is that the concentration, the main reason is that the concentration of the CFCs, which are not just ozone killers, but also very powerful greenhouse gases, has ceased to go up since about 1990. Plus also the concentration of methane has ceased to go up since the late 1990s, has decreased substantially in the 1990s. So there's actually at this point, or of the past roughly 20 years, there's a lot less forcing increase due to the action of all greenhouse gases than has been assumed in 1990 or actually beyond 1990. So the world in this case, in this respect, looks actually a lot better than what we thought the world was going to look like in 1990. Namely, the greenhouse forcing is progressing at a much slower pace than we thought like 10 or 15 or 20 years ago. Now, we hear about the arguments that why the temperatures have not gone up as fast as predicted by the climate models, the sulfate cooling argument. Now, I run through some of the steps about the sulfate cooling. Sulfate emissions occur 90% in the northern hemisphere. According to mainstream modeling, the cooling effect is strongest there. You can actually look up a lot of model calculations and to prove the point. Don't show any pictures here, but you can see for yourself if you go on the internet and try to find it out. So that should have resulted in larger warming trends in the southern hemisphere, particularly over the continents, than in the northern hemisphere, which is not being observed in recent decades because in the recent decades, the mid-latitudes and the high latitudes of the northern hemisphere are warming, and not the other way around, not in the southern hemisphere. Now, the sulfate cooling hypothesis is a very heuristic assumption. It's a cancellation, basically, of two large unknowns with opposite signs. It is hypothetical and speculative, and there is no real firm scientific basis. It is not entirely impossible, but it's not very plausible. And it follows, in fact, the general trend in the climate debate, namely hypotheses that support model predictions are stressed and countervailing evidence is played down by scientists and the media. Now, what are the other possible explanations for the large differences between model and observed? We have heard some of the reasons already. Namely, there is a strong water vapor feedback, which may not be as large as modeled, especially in the tropics. Dick Linson has done some work on that. Plus also the cloud feedback, which may not be as large as modeled. There's actually a large disparity between various model calculations. My next question is the observed warming in recent decades entirely due to man-made global warming? Warming during the first half of the century, as we have seen before, is almost entirely due to natural causes, possibly solar. The cooling in 1950, 1975 is obviously also unrelated to greenhouse gas increases, possibly solar. Warming over the last 3 decades was concentrated in the mid and higher latitudes of the northern hemisphere, relatively small insignificance in the tropics, and that is this is post-1980 and not between 1976 and 1980, or between 76 and now. And it appears to be influenced by ENSO variations, which are more frequent since 1977. And it appears also to be influenced in the northern hemisphere, mid-latitudes winter, by the NIO, the AO, or the northern annual mode. So more zonal flow in recent decades, wintertime warming in interior continents, larger at the surface, smaller in the free troposphere, which probably explains a significant part of the northern hemisphere temperature rise. Part of that story is in fact detailed in the IPCC report. I give you here the temperature, the satellite temperature trend, the MSU2LT trend 79 through 2006, and you can see by this right here that the warming of the southern hemisphere is only about 1/3 of the warming in the northern hemisphere, and obviously the global warming over the last close to 30 years is somewhere in the middle at 0.14 and 0.07 in the southern hemisphere. Now, next I show you the relationship between the SOI variations, ENSO cycles, and the thickness temperatures, 300 over 1,000 millibars in the northern hemisphere since about 1961. You can see a clear trend, and somebody else has shown the graphics. I think Bob Balling showed it. There's a clear relationship between El Nino cases and La Nina cases, and you see most of the La Nina cases you find in the 1960s, 1970s, and most of the El Nino cases you find in the 80s, 90s, and even a few after the year 2000. Next picture, the intensity of the polar vortex has a strong relationship to the intensity of the zonal flow in the winter times, mid-latitude continents. And you see there's a clear relationship between the strength of the vortex and temperatures in the mid-latitudes in winter. This is, again, the tropospheric temperatures. So this is a strong vortex. That's the departure of the 1,000 millibar surface in geopotential meters, so a strong vortex, warm in the mid-latitudes, and vice versa. Now I've compared this with over the Eurasian continent, 50 and 60 north, wintertime, last 20, no, this is actually only 79 through 1998 for some reason, but in any case, what you can see is that you have a much larger surface warming than in the mid-troposphere. Why is that? because if you have a strong zonal flow over the continental interiors, that means you do away with the surface inversion, and you have much larger warming at the surface. Even though you don't have much warming in the mid-troposphere, you can still have a large surface warming because of the thermal inversion effect. You do away with the thermal inversion. I show this picture just to address some of the possible reasons that there may be for the difference in temperature change between the surface and the mid-troposphere that we've seen in the satellite record, but also in the radiosonde record. Now, significant increase of extreme weather events. Model predictions on increase highly uncertain, does not entertain the view of a definite increase in intensity and frequency of hurricanes in a warmer world. Countervailing evidence of effects of increasing static stability, vertical wind shear to the higher SSTs in the tropics and the hurricane formation regions. Model predictions on mid-latitude storm intensity in a warmer world, highly uncertain, modeling errors larger than climate change signal. And also the equator to pole temperature gradient is the main driver of mid-latitude storm intensity, which is projected to decrease because of larger warming in higher latitudes than in mid-latitudes. Here I've taken a picture out of a presentation by Ruth McDonald from the Met Office, and which shows several models, calculations in a table here, and shows the frequency of hurricanes in a future warmer climate by ocean basin and by model. And you can see there's generally no clear picture. As a matter of fact, there seems to be preponderance on actually less frequent hurricanes in a warmer climate, but not really a clear picture of increasing frequency of hurricanes. The next graph I've taken straight out of a presentation by Leonard Bengtson from the Hamburg Institute of Climatology. It says tropical storms and climate change. There's a minor reduction in the number of tropical storms. There are no changes. Those are his words, not my words. This is straight taken out of his his talk, actually. In spite of a tropical increase by 2 to 3 degrees, marked changes in the region of tropical storm. But from this, you cannot deduce that tropical storms will become more intense and more frequent in a warmer climate. This, again, has been taken out of the presentation by Ruth McDonald from the English Met Office. And look at the summary down here, and this is the important message. All models have systematic errors in the simulation of cyclone tracks, and errors are often larger than the climate change signal, meaning there's no way you can possibly or certain project any changes in intensity or location of extratropical cyclones from current model results.